Got a Sony TCD5M in for service. This one was sent in from a viewer who said it hasn't been used in a long time and it's not running at the correct speed. So we're going to take this one apart and see whether we can get this one to operate properly. I have a Sony TCD5M in to check out and see whether this one can be repaired. So fast forward is kind of sluggish, but it works. Rewind works. How about play? Okay, so there's no take up. The take up idler is not moving, but let's just see whether it turns on and see what type of speed we can get off of this. See how the speed is, if it's going to play anything at all. Okay, so it's playing really slow, and the take-up idler is not turning. This might be related. It may be dragging the caption speed down because the play is not turning and it's idler driven. First I will remove the batteries. I'll start out by saying that these are not my favorite units to work on, only because, well, you'll see the board itself has limited markings on the board. So some components are marked, most of them are not. And there's a lot of wires, very fine wires that interconnect between various sensors and switches and so forth, and the circuit board, and they're attached on the foil side. And none of them are labeled. So if one breaks off, you have a heck of a time figuring out where it goes, because it's quite a mess inside, as you'll see shortly. These recorders are quite sought after these days, so we try to keep them running when possible. Sometimes you can't get parts for them. This one here appears to be sort of running, and it may just require being cleaned up, possibly a belt or two in it. We'll see how the belts look once I get into it. We'll remove the screws from the cabinet. Now we need to, oh, someone's been into this. Look at all the nice green tape that's holding the wires down. Now the video is not going to do this justice because it's not a real-time repair. The time that this was on the bench was between 6 and 7 hours. Remove the circuit board next. You actually have to disconnect the DC to DC converter. Note the time, it's 9:23 p.m. when I started working on this, and I'll be working on it till probably, I think about, I don't know, 1 o'clock in the morning or later, and I still didn't finish it. I had to finish it the next day. But we need to disconnect the battery. I think this is the input, the battery terminals for the DC to DC converter. Because this unit runs on 3 volts, but the circuitry actually requires plus and minus 9.5. They have a DC to DC converter module, which takes the 3 volts coming in and provides the higher voltages. The motor and servo run off the direct 3 volt battery voltage, but the amplifiers and Dolby circuit require the higher voltage. To get at the mechanism, we need to take the board out, and that means disconnecting this converter over here. So looking to see if there's any other screws that need to come out. Got one more here. They're all marked with, there's 2 more actually, they're all marked with arrows on the circuit board. Okay, now the wires are out of the way. Should be able to lift the board up so that I can get at the mechanism that's below here. Now, one of the things I really don't like about the design of this is the fact that it's got all these wires and it doesn't take much for them to break off of the board, especially if they've been moved a few times. So you got to be kind of careful that you don't lose any of the wires.
That big brown cap sticking off the board is actually the sample hold cap for the capstan servo circuit.
It's also a good idea to take a picture and note where they go in case they do break off. Okay, now we can examine the belts and see how the belts are on here. There's a couple belts on these machines. We'll just see how they are. Don't appear to be in too rough a shape. That one's still got a fair bit of tension. And this one here is still not in bad shape. And that one there has a fair bit of tension too. If any belts need replacing, it's more than likely this one. This is the one that usually goes bad. It's one of the main drive belts. This one's actually part of the auto stop though. And there's another belt down here that also can go bad. Let's just see how the tension is on this one. This one's looking to be not in too bad a shape either. I think I've got that one. One part of the mechanism that's gummed up is this part here. This mechanism here. If I take off this belt, this wheel is not turning freely. So we're going to start by cleaning up this cam gear and stuff down here. This I think is part of the auto stop, but it's really it's gummed up. Neat thing about this is I can operate the motor right without the DC to DC converter, because the DC to DC converter is for the electronics. So if I put batteries into the unit, I can operate the mechanism and see that things are turning without having this connected. This is just for the amplifier board. So if I put it into, say, rewind, for example, we'll see that the rewind will turn, and there's actually a fair bit of torque. It'll actually almost stop the flywheel from turning. So that belt is in okay shape. Fast forward is not moving because the mechanism is gummed up. This belt here is slipping, and it's slipping really because the mechanism below here it's stuck. So we have to change this belt, but for starters, let's get this mechanism that's gummed up cleaned up, and then we'll deal with this belt in a few minutes. But let's start with this part of the mechanism. And this is gummed up here. This gear doesn't even want to turn. Seems like it's this one over here that's the one that's the problem. This gear here, which operates the auto stop mechanism. We'll just take off this cut washer and pull this top gear off. Okay, lift that gear out of the way. Gear doesn't want to move. It's so gummed up.
These gears are made out of a type of plastic that actually deteriorates.
I don't want to break it, but it will lift up.
So you gotta be really careful
Pokes it
taking
up
this
out
gear
of
out
here a bit.
because they become very brittle.
This gear is really stuck. This is probably the biggest problem with this unit right now, is this gear here. It's frozen to the shaft. Be careful, I don't want to break it. It will lift up, it's very, very, very sticky. Okay, so you can see down on this shaft here, it's all gummed up. That's why it's not turning. You can see the remnants of the lubricant. We're going to clean this up and see if we can get this gear to turn a little more free than it was. The other ones appear to turn freely, right? There's no binding on these gears, just this one. This is part of the problem, if not the problem with this unit, at least as far as the unit itself not turning. Get some isopropanol, clean up the remnants of the dry grease or oil or whatever they used in there to lubricate. I'm sure it's a lithium type lubricant. You wouldn't put a petroleum base on here because it's plastic. This would be a lithium soap type grease. I'll use my Molly coat for this because it's safe on plastics. We'll do the same for this gear here. Try to clean it up a bit as best possible. So we're going to clean the gear by putting some cotton into the end with a screwdriver and just rotating it a bit, and this will clean out the inside of the gear here so that I can get a bit of lubricant on here and put this back on. I'm going to use some Super Lube synthetic grease with PTFE. Put a little bit of that on the post and a little bit into the gear, into the bottom of the gear. And as you can see, this spins freely now, whereas it wouldn't even turn before. So I'll put the cut washer back on top. Put a little bit more on this shaft here and into the gears. and put the E-clip back on top.
Magnetic tools can be a godsend or a curse depending on what you're trying to do. Sometimes they're a real pain to get these clips back on.
Together that they're going to fly off someplace on me, so put the hand on top to clip it in place. Now that turns freely. Now let's see how it turns with the flywheel. Put power to the unit. Fast forward. Fast forward is turning. Rewind is turning. And forward is turning. Let's check out changing those belts. I'll start out by removing the stripped already screws. Somebody else has already stripped nicely for me by using the wrong screwdriver. With the motor bracket out, then I can access the belts to change them. We'll get that belt out of the way. I'll certainly can find another one for that. I probably have these other belts too. That one there is just, I think, the counter belt, so we don't really need to worry too much about that one, but this rewind belt here should probably be done. I'm sure I've got one of these kicking around. So let me just see if I can find some appropriate belts. One belt here. This is the rewind belt.
As you can see, these units are quite tedious to work on, and that is why they are quite expensive to repair. Not as bad as the recording Walkman, the professional Walkman like the one that I have, but still a lot of work to get into the mechanism just to change little belts and to lubricate.
And then this one here is
the idlers.
I think this is the play and auto stop belt. And now I can put this bracket back in place and see what else we need to do to this unit to get it operational.
These tape recorders were real workhorses. They were used extensively by radio reporters, going back into the 1980s from when this was manufactured, right up until the point where digital recording basically replaced them. But every reporter carried one of these around with them. It's just because the quality was good enough that they could go to air with a recording off this and it would sound fantastic.
Okay, put the batteries in and we'll check this thing for torque now, but this should have a lot more torque than it did before. Should be driving the take up and supply spindles with full torque now. Let's see how it looks. Lots of torque there. Lots of torque there. And just about the right amount of torque for playback. Does the auto stop work? Does not appear that the auto stop is working. Auto stop and rewind works. Should shut off. There you go. And fast forward. And it works. But the auto stop on play is not working just yet. And that's that gear here. That's this one here. I think this lever is probably stuck. We'll see here. Let's just make it run in the play mode. Yeah, this lever's not moving. This lever's supposed to be moving back and forth. Why is it sticking? I think the auto stop lever is just on the wrong side of one of the levers is in the wrong position. So we'll remove the bracket once again. Oh, damn screws are not very magnetic, are they? I believe it's this lever here is sitting on the wrong side of I believe it's supposed to be riding in. There's a groove here. There's a groove down here. I think this pin is supposed to be riding in this groove here. So I can pull this out of the way. There we go. That I think is where it's supposed to be. So that this can ride back and forth like this. There. I think that's where it's supposed to be. It goes on like that. The belt goes on, and then this plate, the motor bracket, goes back on like this. Yes, I know I haven't put the counterbelt on yet. I'm fully aware of that. Don't need to tell me. You know, somebody's typing madly right now. He didn't put on the counterbelt. Yes, I'm aware of that. It's called testing the mechanism before putting it together. If you wonder what this is a special screw or a special mounting post. It's got a screw on the back because a threaded screw on the back because one of the circuit board screws actually connects to that right here. It screws through onto that. That's why that type of mount. Okay, now we'll put that counter belt back on while I think about it. And a wire breaks off. Wonderful. So the problem with all these little thin wires is that you just got to look at them the wrong way and they break off. This one goes to a little switch. So we'll just resolder that one momentarily here. Okay, that's got that part fixed. This should have the mechanism functional now. We can test it again before putting the unit back together. Okay, I'll put it into play. And I can see the auto stop mechanism is now working as it's supposed to, you see. The lever is riding back and forth. So when I stop the take-up spool from turning, it should stop the mechanism. So I'll stop it by hand, watch the mechanism operate. Okay, I'm going to stop it right now, and it should kick it and stop, which it just did. So that works. So time to start putting the unit back together. Hopefully we won't break off any more wires in the process. That's always the concern with these units, with these fine wires, is that the fine wires are going to break. Looks like someone changed this capacitor in the past and just stuck it on the back side of the board. Doesn't it? Looks to me that's what changed on it.
Note the time. It's now 10 o'clock. I've been working on this thing now for about 45 minutes. And we're not even close. I'm going to get it hooked up, and then it's going to be the sound of disappointment, as you're going to hear pretty quick.
Also, somebody was doing something here. Yeah, like it looks like they've put nail polish or something on the board right there, doesn't it? Maybe they secure down wires. Some soldering's been done over here as well on this unit. Or reconnect the DC to DC converter so I can test this audio amplifier and make sure that we've got sound. And yes, it is warm. It is warm when you touch your finger on molten solder like that. I'm just used to it. Don't recommend it. If you don't like that burning sensation, don't do it. All right. 440 test tape. Rewind. Fast forward. Play. Controls dirty. Speed is way off. This is a servo motor on this thing, so let's just turn the speed up a bit. Where's our control I can adjust? Wow, that's really slow. That's really sad. Well, it's a couple things we could have. It could be a bad motor. It could very well be a bad motor because the motor is variable speed. It's not slipping. It's not slipping on the disk drive unless I pull it away. But if I put any more, like, it's not slipping. But you see, it slows down real easy. Like the motor doesn't have enough torque. What I can do is I'm going to pull this thing apart again and just check the flywheel and see if anything is binding the flywheel. But it could very well be the motor itself has got a problem and it's not going fast enough. The servo circuit's working because I can control it, I can slow it down. I've got it running full speed though, and it's still going far too slow. So we'll pull the board out again just so I can get another look at the motor before I condemn the motor, but it could very well be that the motor itself is just shot. My favorite design, I tell you, not. So basically the motor just rests up against this rubber flywheel and spins the flywheel. I'm going to lift the flywheel right out and just see how the bearing is on this. This will just lift out. Careful. See, there's nothing dragging on the flywheel. The flywheel itself is in good shape. And the belt is not too tight. I mean, this belt is designed to be relatively loose because otherwise it can drag, right? So there's no excessive drag here. Put a little bit of grease on top of the flywheel here. So that's a shot of the servo. As you can see, it's certainly calling for more power from the motor, but the motor is not spinning up. That was pin 8 we were looking at. Here is pin 5. Same thing. Pin 3. Pin 2, that's the FG coming from the frequency generator off of the, and that's the sawtooth, that's pin number 1.
Pulled up a schematic. Let's check the operation of the servo.
Looking at the scope, this is the IC that I was looking at here, IC 702. So we had the sawtooth wave generator was working, but you could see an instability through the wave shaper on pin 2 and pin 3. And pin 6 was the output, which this was showing that the actual circuit was working because it was calling for more speed, but the motor can't deliver any more speed. We're going to try something with the motor here and just see. I think maybe there might be something jamming the motor. So let's just try and see if we can get that motor to run a little more free. There appears to be crap binding the motor right in here. There's this. Look at this stuff that's in here. There's fuzz around the motor. I'm curious as to whether this is causing this thing to bind up. Can you see it? Hard to see. Let me shine some more light in at an angle here. Can we see it down in here? There looks to be, you can see it here on my, see some fuzz? There looks to be a bunch of fuzz around that motor. I'm just going to try something with this and just see if I can clean this up. So what I'm going to do is I'm going to unsolder the motor, and I'm going to power the motor up externally. The wires for the motor are the red and the white wire over here. With all the other wires in the way, it's hard to see them. There we go. Okay, so the red and white wires soldered down here and here. So I'm just going to remove them so I can apply external power. I'm going to try something different. Now, when it's not in play mode, the motor is not engaged to anything, so the motor should just run and spin freely. I'm going to power these up with my power supply, and I'll give it a little bit of excessive voltage just to make this thing spin up quick. But I'm going to run it backwards, because if there's been something that's been, if there's something that's wound around that motor shaft, I want the motor to turn backwards so that I can try to clean it out. So we get the motor spinning. Motor spinning good there.
The light is in the way, unfortunately, but a bunch of fuzz came out from around that bearing, around the motor shaft and the bearing. Well, the speed's a little better, but I've now noticed that the play idler is kind of stopping. So we're going to pull the top off this one and see. I mean, I've spent so much time on this thing now. Check the timeout. It's almost midnight. I'm going to have to call it quits at some point, get some shut-eye before I finish this up. But this has just become one thing after another, but I think we're going to get it. But now I've got on play the take-up stops intermittently. So we got to pull all the screws out to take the top cover off and take out the cassette compartment and see what's causing it. And that's not all, because I'm going to have to go into the bottom again, because when I do figure out where it is, it's actually accessible from the bottom under the board. So I'm not going to have to pull the board out again for probably the 6th or 7th time. They are not fun to work on, but I think I've already said that.
Okay, what's under here? Don't see anything sticking.
as you can hear, the speed is a little sharp now because I've been playing with the speed control, so I haven't set it back. So I got the motor speed up. That was just a bunch of crap that was gummed around, like fuzz that was gummed around the motor shaft and the bearing. So I've got that part working, but I still got a mechanical problem that I'm dealing with right now. As I say, it's taking a lot longer than I had anticipated when I got on this thing. I figured I would be in and out of this thing in an hour or so, and here we are, going on 4 hours, and I'm still working on it, and I've still got a lot of work ahead of me.
Play idler slipping a little bit. That's expected. That's this idler right here. In the bottom again, I'm just going to do this idler here. This one seems to be gummed up a bit. This is the fast forward idler. So we're just going to pop this one off and just clean this one up a bit. This one seems to be gummed up a bit on its spindle here. So one more time to go under here. Take this idler off. Just see what it's like underneath here. See, it's not gummed up or anything. It doesn't appear to be anyway. But we'll clean this off. And put some lubricant on it. Okay, now I got the board back in, the batteries back in. Let's just see if we're any closer in speed. Oh, we're right on. We're fairly close. Incredible.
I adjusted it by ear before turning on the guitar tuner. Still got a bit of a slippage here. Or it slipped a bit there when I turned it on upright.
Well, fast forward is still slipping a little bit. Maybe we can get that idler just to get going there. I'm going to put some rubbery new on the fast forward tire down here. I have to keep turning the rewind side because if I stop, it'll go into auto stop. See? The auto stop for fast forward and rewind is actually on the rewind side, but that's got a fair bit of torque now. How's my play torque? My play torque is pretty good too. Slipping a tiny little bit. Let's see if we can get some rubbery new on that one too. That one's down here. We have to pull the bottom off again for that. It's actually not bad. Let's just see how it works. Run this thing for a bit. A little bit fast, but I can adjust that. Servo's working now. Control's bad. What else is bad on this thing? It's been sitting so long.
If someone asked me whether I felt that a belt drive was better than the rim drive or this idler drive, as this has got, disc drive as Sony call it, yeah, I would have to say I think a belt drive probably is better, just because of the fact that the motor on this has to make a physical contact with that rubber. As that rubber edge wears, it can cause speed inconsistencies.
That's probably about as close as I'm going to get this. Pretty darn close. Fast forward and rewind is now working. Do I dare play the 3 kilohertz side and see how much flutter this thing's got? These things should be very low on flutter because it's a disk drive, but the problem is the disc itself, the rubber deteriorates on the surface of that disc drive. Not bad. It's pretty good. You know, for the age of this thing, I'm going to say that that's probably acceptable. I'm going to run this just for a little bit and let the lubricant that I've put on work its way in, and we'll pick this up in a bit. I'll start putting it together and see if it holds its speed good. Now, what you guys didn't see that happened off camera, because there was a lot of testing going on here, but I was looking at the servo circuit with the scope. This is a feedback circuit on this unit. So you've got this is the auto stop control, by the way, but there's a rotation detection here, frequency generator on the flywheel that provides a feedback signal into IC701, the FG amp. The FG amp provides a waveform that goes into IC702, the speed control IC. This is where the speed is monitored on that flywheel. And speed control here, VR701, is what determines the free running speed. And it was calling for more speed, but the motor itself wasn't able to get fast enough. I lubricated everything. Lubricated the flywheel. Flywheel was turning freely. Everything was looking like it was working, but it wasn't. Seems to be working a lot better now, especially since it's been running. Now, it could have been the motor itself also. There was a bunch of fluff that was entrapping in the motor here, inside the, right in the spindle here, where the disk drive is. There was a lot of fluff in here which I cleaned out, so that could have been part of the problem. It's certainly running much closer to the correct speed now than it was before. So the next thing is I'm going to just let this thing play. I gotta clean that control too, but we'll get to that. We'll clean the controls up on this. I'm going to call it a night on this now. I've been working on this thing for, I guess I've got about 4 hours of time into this so far today. So this is the only thing I've accomplished today, is to get this thing actually running. So I'm going to let this run and just let it run for a while, and we'll clean up the control. I'll do that in the morning. I'm calling it a night now. I've been working on this thing. As I say, it's like 12:38 in the morning. I've been working on this thing all night. The video has been condensed because I haven't run the camera the entire time, but I've had this thing apart about 6 times. I've had that board out 6, 7 times maybe, taking that mechanism apart and checking everything and putting it all back together, and it was constantly running slow. Alright, the unit's been sitting overnight. We're going to check it again today and see how the speed looks. Right on the money. So I think we'll put a tape and just listen to a music tape, and then we'll start to reassemble this unit. I should make a recording on it too. But somewhere on my desk here I've got a music tape. Oh, I gotta clean these controls too. I almost forgot about that. Let's do that first before we reassemble this unit. Let's clean the dirty level controls, and then I'll make a test recording, and then we'll start reassembling this unit, because I think this is probably as good as this one's going to get, considering it's pretty much dead on speed. It's had 2 belts replaced. I didn't replace the counter belt. I replaced the main drive belt and this one. Well, this is the play belt. This one operates the auto stop and the play mechanism. And as you can see, it's pretty deformed. Although this belt probably can be brought back by boiling, brought back to shape. And this one here is also, it's not melting, but it's just lost some of its elasticity. And this belt could probably be brought back by boiling too. So I'll try that at another time and see whether I can resurrect those 2 belts. But first things first, let's clean the level controls for the volume, the monitor, and for the recordings. And we'll check the recordings, see how dirty those ones are. If I put this into record mode and forward, how do I do this? Like that. I don't know whether this is going to let me hear what I'm doing. Probably not. The monitor speaker is probably off when it's recording in record mode. Let's just loop something through it so I can see how dirty the control is, and then we'll do a test recording on it and see whether the record level controls are also bad. We know that this one is for sure. Those controls don't sound too bad, but we will give them a shot of cleaner because we've got the unit apart. Might as well do it right now. Yeah, it's 2 controls. 2 controls. I gotta get cleaner into this front control as well. So there's a control right here, and then there's the back one. So that should clean both of these controls up quite nicely. We'll also clean the monitor control over here for the playback. It's just a single, I believe it's just a single control on this one because it's just a mono amplifier for the little speaker. There, a little better. Now, you get a bit of wow on these older units. It's because of the rubber ring on the flywheel is starting to deteriorate. That is the, I guess you can't see it from here. Maybe you can if we get the camera focused in. The motor is what they call a disc drive, which is equivalent to the old, wait for the camera to stop shaking there, which is relatively equivalent to the old idler drive turntables. You can see that the metal motor shaft there, it spins a rubber ring. Well, you saw it when we had it apart, but there's a rubber edge on the brass flywheel. And over time, that rubber becomes kind of uneven, especially if the unit's been sitting around for a while, and they just wear, and there's not a whole lot you can do other than replace it, and getting a part like for one of those now is pretty much impossible. Unobtainable, they would say, as the saying goes, right? But that's basically what it boils down to, is that part wears. And as it wears, you get a bit of wow, get a little bit of flutter. They're still very good considering the age of it, but that was a part that did wear out on these units. So that's something to keep in mind. If you're looking at buying one of these old units, they do wear out. They were great in their day, but they do wear out. There's the 3 kilohertz tone. There is a little bit of wow there, but it's to be expected for a unit of this age. So let's start to reassemble this unit. So you guys remember what the old belts looked like? I just showed you, right? Well, here's what they look like after they've been boiled for 10 minutes in a microwave. Lots of elasticity, and they've returned pretty much to their original shape. And these would probably work perfect if I put them in here. I'm not going to because I've got new belts in here now, but these would probably work perfect in here if I were to put them back in. So just open this up, because this has got to be out of the way for that to fit in. That goes in first. And tighten down the rest of the screws. Moment of truth. We'll plug it into the real system here and listen to it through some real speakers. Rewind works. Fast forward works. We're going to make a test recording and see how it sounds. And then we'll call this one done. Well, I thought I was going to be able to call this one done, but obviously a wire has come off because it's going into auto shutdown on rewind and fast forward. Damn it. Auto stop for forward and reverse or fast forward and rewind on this unit is through a magnetic sensor. There's a Hall effect sensor. You can see it right here. And that Hall effect sensor detects this magnet that spins when the supply spool spins. You see the spool there? There's a magnet on the back side of that, and that's what the Hall effect sensor detects. So it's possible that the Hall effect sensor is just not quite in the right position. I'll just try repositioning this little sensor a little bit closer down towards the magnet. Maybe that's all it needs, is it's just out of position a bit. Okay, let's try that. I just pushed it into position. Let's see if it will rewind or whether it will still stop. Ah, good. That's all it was. It must have got, when I reassembled this for the last time, it must have got pushed out of position. Whew, that's dodged a bullet there, because I really do not want to have to pull this whole chassis out again. I get nervous as it is taking these out once, never mind having to remove this board like 6 times, which is what I did in this case. I took it apart about 6 times. And every time you take apart one of these units, there's a chance that one of those wires is going to fall off. And they're not very well documented as to where they go. So that's something you want to try to avoid at all costs, having any wires come off on it. It could make a long repair even longer. And the time that's been spent on this unit now is about 6 hours. Saved by the bell. Somehow I think it's not for me though. And how would I know that? Because it's never for me. Seems like the only time the phone ever rings, it's someone telling you that your credit card has been compromised and that there's been a $1,300 charge applied to eBay, and or it's the Canada Revenue Agency telling me that there's a request, or there's a warrant for my arrest, or it's Canada Border Services telling me that a package that had been sent to me has been seized and that there's a warrant for my arrest. That's usually what happens. Okay. There we go. I was looking for a section of this tape where there's nothing recorded on it so that I can do a test recording. And that's how I discovered that the auto stop was tripping prematurely because when I went to go into fast forward, yeah, I'll record here. All right, let me just set my record levels. Pause, record, forward. And we'll I'll cue that track up. And we'll record it. I'll play it back directly through the camera like we usually do, and see how it sounds. Okay, there we have it. TCD5M was sounding like crap when it got here. It's actually sounding pretty good now. Thanks for watching. We will catch you in the next one real soon. Bye for now.